Hello everyone, welcome back to the channel uLearn Education Online.
In this video, you are going to see how many modes of operation are present in differential amplifier circuit and how the circuit of modes of operation will be. As we know that in the previous video, we have seen and we have briefly discussed about the differential amplifier circuit and how it is designed by using a simple emitter biased circuit. Now in this video we are going to see what are the modes of operation in differential amplifier circuit. So this is the previous differential amplifier circuit we have discussed. So here we are having two input signals Vin1 and Vin2 and the two output signals Vout1 and Vout2. Okay, so two input signals are there, so that's why we can call it this differential amplifier as dual input, and two outputs. Across the two outputs we are obtaining the output signal. That's why this circuit is named as dual input balanced output differential amplifier. Now here the modes of operation will be divided depending upon the input signals of the differential amplifier circuit. Now what are the input signals? Vin1 and Vin2 are the input signals of the differential amplifier circuit. So depending upon these two signals we can define the modes of operation. Suppose if the two input signals are same, then we can call it as common mode operation, and if the two input signals are different, then we can call it as differential mode operation. So depending on this circuit, the modes of operation in differential amplifier are two. One is the differential mode of operation and second one is the common mode of operation. So now here what do you mean by differential mode of operation? In this differential mode of operation for the circuit, these two input signals Vin1 and Vin2 are different. They are different in the sense their amplitudes are different, or else their amplitudes are same but the phase angle are different. Okay, depending on the signal parameters we can define that these two input signals are different. And second one is the common mode operation. So here the common mode operation means the two input signals are same. Two input signals are same in the sense that the two signals are having same amplitude, same phase and same frequency. So from this circuit diagram we can simply write the differential mode means these two input signals are different. That's why we can write it as Vin1 is not equal to Vin2, whereas in common mode these two signals are same. That's why we can write it as Vin1 is equal to Vin2. Now we are going to see how the circuit diagram of differential mode looks like and how the common mode looks like, and the explanation of each mode of operation using this differential amplifier circuit. So now let us briefly discuss about the differential mode operation in differential amplifier circuit. We know that in differential mode operation the two signals are different. The two input signals are different in the sense they may differ in magnitude or they may differ in phase shift. Okay, so here for easy purpose we are assuming that the two signals are having same magnitude but they differ in phase shift. So in order to obtain the difference phase shift we are using a center tap transformer to the input of differential amplifier circuit. So if you observe we are using a single signal source. Okay, so we are using a single signal source but we are obtaining the two signals which differ in phase shift. How we have to generate a different phase shift means simply we are using one basic center tap transformer circuit. By using the center tap transformer circuit we are getting the two signals with same magnitude but differs in 180 degrees phase shift. Okay, now assume that a sine wave on the base of transistor Q1 is positive going, while the sine wave on the base of transistor Q2 is a negative going signal. Now Here we will see how the signal response will be present at the collector terminal as well as at the emitter terminal of both the transistors. Now let us consider how the signal performance will be there for the transistor Q1 at the collector terminal and at the emitter terminal. Since with the positive going signal on the base of transistor Q1 at the collector terminal, an amplified negative going signal will develop. For example, if you consider that the amplitude of the signal at the base of transistor Q1 is 5 volts. Okay, so if you observe the amplitude of the signal at the base of transistor is 5 volts, then at the collector terminal this signal amplitude will be amplified. I am assuming that a 10-volt signal is developed at the collector terminal since a positive going signal is applied at the base of transistor Q1. So at the collector terminal a negative amplified signal will be present. So negative amplified means it is minus 10-volt signal will be present. Okay, so at the collector terminal an amplified negative signal will be present with the positive signal applied at base of transistor Q1. Now let us see how the signal will be there at the emitter terminal. So if you consider the signal response at the emitter terminal, so due to the positive going signal at the base of transistor Q1, the current flowing through the resistor Re will increases and a positive signal will be present at the emitter terminal because of emitter follower action of transistor Q1. Means at the emitter terminal the same signal will be present, that is the input of a base. So here at the input of base we are having a 5 volt signal, so at the emitter terminal also we are having a 5 volt signal. So this is the response how the transistor Q1 will act whenever a positive half cycle is applied at the base of Q1. Now let us see what happens whenever a negative going signal is applied at the transistor Q2. So due to the negative going signal at the base of transistor Q2, an amplified positive going signal will develop across the collector terminal of transistor Q2. Okay, now an amplified signal will be present at the collector terminal. Let us assume that here a minus 5 volt input signal is present. Okay, why we are considering 5 volts? Since these two signals are having a same magnitude. So here we are assuming 5 volts. So thereafter at the input of transistor Q2 also the same voltage will be present, that is 5 volts. So here a negative 5 volt signal is applied at the base of transistor Q2, which means that at this collector terminal we are developing a positive signal. So at the positive signal is 10 volts. Now we will see what happens the signal at the emitter terminal. Since a negative going signal is present at the base of transistor Q2, same signal means the same negative going signal develops across the resistor Re because of emitter follower action. So because of emitter follower action, the same signal will be present across the resistor Re, means the voltage at this is minus 5 volts. So the signal voltages across the resistor Re due to the effect of transistor Q1 and the transistor Q2 are equal in magnitude but differ in phase, 180-degree phase. So here we are obtaining a positive current, here a negative current will be there, and both the currents will cancel each other, and hence there is no signal will pass across the resistor Re. Hence there is no current flow across this resistor Re. Now see how the output signal will be there. So here the V0 is the signal that is taken across the collector terminals of transistor Q1 and the collector terminal of the transistor Q2. So we can write this V0 as, let us assume that the collector terminal the voltage is V01 and at the collector terminal of transistor Q2 the voltage is V02. Now how we will write V0 as V01 difference V02. Okay, so if you consider this example we have considered, so V01 is -10. So V01 is -10 and V02 is -10. So these two signals will get added. Okay, why? Because I have written here -10. V0 we can write as difference of V collector terminal voltage and the collector terminal voltage at the transistor Q2. Therefore, a signal output signal will be present in the differential mode of operation. Therefore, in the differential mode of operation at the collector terminal, we are obtaining the output voltage, that is the difference output voltage V0, in which these two signals of the collector terminals of transistor Q1 and Q2 are gets added up. Whereas if you observe the signal value at the emitter terminal, since these circuits are emitter biased, the signal voltage appears across the resistor Re will cancel each other, and hence there is no current flow across the resistor Re. So which will increase the differential mode gain of the differential amplifier. Now let us see the next concept, that is common mode operation. So in this mode, the two signals are having the same magnitude and same phase, means the two input signals are same. If you observe the circuit, the two input signals of differential amplifier are connected to the same source, indicates that only one signal source will be present. Now let us see the explanation. First, we will observe how the signal response will be there at the emitter terminal. Thereafter, we will observe how the signal response will be there at the collector terminal. Now, you can observe that the base of transistor Q1 and the base of transistor Q2 is positive going signal. Since at the emitter terminal, if you observe, these two circuits are emitter biased circuit, the same signal voltages appear across the resistor Re, which will add together. Means, for example, if you assume that the two signals are same, means here a 5 volt signal will be present at the base of the two transistors. Okay, so here 5 volt signal, and here also a 5 volt signal will be present. So at the emitter terminal, these two signal voltages are added up. Finally, we are obtaining a 10 volt signal at the emitter terminal. So because of this, the resistor Re carries a signal current and provides a negative feedback to the differential amplifier circuit. This feedback reduces the common mode gain of differential amplifier. Okay, this is how the signal response will present at the emitter terminal. Now we will see how the signal response will be present at the collector terminals of two transistors Q1 and Q2. If you see the example, the two signals are having positive going signal at the base transistor Q1 and Q2. So an amplified negative going signal will be developed at the collector terminals of transistor Q1 and Q2. So here a 5 volt signal is applied at the base of transistors Q1 and Q2. So at the collector terminals of transistors Q1 and Q2, an amplified signal will be present. That is, let us assume that we are obtaining a -10 volt signal. Okay, so if you find out the output voltage difference across the collector terminals, then the output voltage across the collector terminals is equal and is also in same phase. Therefore, we are obtaining a zero voltage. So V0 we can write as -10 minus of -10, which is equal to 0. Thus, in the common mode operation, the output voltage is almost 0. Negligibly we can say that it is 0, but practically some output voltage will be present. This is how the common mode signal will be rejected in the differential amplifier circuit. Thank you.